Alrighty, so let's get started with our presentation. What we'll do today is just talk about our program. Again, as we're going through this presentation, I do encourage you guys to make sure that you are muted, that your microphone is muted, and then we'll just continue to go from there. My name is Chris Lundy. I am the Academic Advising Manager for the School of Aerospace Engineering. We'll introduce our team here in a second. But this presentation will talk about our program, different research opportunities. We'll talk about our courses, different facilities that we offer. And as you have questions, please feel free to put them in the chat box, and we'll continue to answer them as we go along. Okay. We'll be providing links for you guys all day in our chat box, so please feel free to click on those and view them at your leisure as well. Again, today's session is recorded, so I will put my information in the chat box later so that if you do have questions or you want to go back and review it, you can email me and I'll be sure to get you a copy of today's recording. All right. So we do have one other advisor in here. So Kay, I'm going to let you go ahead and introduce yourself.
Hi everyone, Kay Doring, Academic Advisor as well for Aerospace Engineering. We're glad to have you here today. We hope we can answer all of your questions and we
Good deal. Thanks, Kay. All right, so I am going to put up my presentation, and so I won't be able to see the chat box, but Kay will. And so again, as you guys have questions, please feel free to let us know in the chat box. All right, so give me 1 minute here to share my screen. All right, so let's get started. So again, on behalf of our team, we want to welcome you guys to today's today's session on aerospace engineering. And this is why you guys are here. Our rankings, they speak for themselves. Georgia Tech speaks for itself. So, this is why you guys really want to be here and be a part of the aerospace program. So, as it relates to research, we are number one as well, not just the theoretical research, but actually applying that research, be it in a classroom format, a lot of different projects within the classroom or research projects that you guys can jump on. You can get academic credit for it. You can get paid for it. We have a variety of options there as well. So great opportunities to work with our professors, work within their labs, work with grad students, and work with research engineers as well. So those opportunities would be available to you all. All right. So this is a breakdown of what our population looks like for this semester. So Georgia Tech is a publicly funded institution in the state of Georgia. So our overall population, when you consider not just engineering, but computing, business, Ivan Allen, everywhere here at Georgia Tech, is going to be 60% in-state, okay, and then 40% out-of-state and international. Specifically for aerospace engineering, I would say for the most part, we're right around 50-50, okay? So, a great mix of students who are coming right here, either in our backyard, or students who are out of state and international. And kind of a breakdown there in terms of the overall applicants within aerospace engineering, those who do get accepted, and then those who actually choose to enroll into Georgia Tech. And then once they do enroll, you can check our graduation rates there. So we definitely want our students here, and we're definitely going to continue to work with our students to make sure that they get all of their experiences and make sure that we graduate them within a timely fashion as well. All right. Just some more information as it relates to our program. Again, we're just going to continue to harp on research today. 84% of our students are participating in a research opportunity, be it on or off campus. And we have plenty of students who are participating in an internship or co-op as well. So a lot of great experiences there. And then students who talk about post-grad plans, be it graduate school or employment, things like that. We talk to our students about that as well. So a lot of great opportunities that are going to translate to even more opportunities. So a lot of doors are going to continue to open within our program, and we're very excited to have our students here. So these are some of the questions that I hope to answer for you. Again, just want to reiterate, today's session is recorded, okay? And so if you guys have questions even after this, please feel free to reach out, and we'll get you a recording of today's session, all right? So let's answer that first question. What do aerospace engineers do? this is what we do. We work with a wide range of aerospace systems. So for example, we're talking about fixed wing aircraft. So students will be in the field of aeromechanics, aerodynamics, working with composite materials, working with low drag designs, working with autonomous systems, both in different disciplines, not just fixed wing, but spacecraft and rotorcraft with the autonomous systems. So you're talking about computer software as well. With spacecraft, rocket craft, you're talking about high energy, high density fueling. So also learning about combustion and propulsion and talking about optimum trajectory. We had a few students, a few alums who were actually on the Perseverance project with NASA, last year. So, kudos to them. But, this is basically what our students are learning. So they're designing, they're analyzing a lot of system and components. They're working in other areas as well. And ultimately, what we want to do within the field of aerospace engineering is make things both financially friendly and environmentally friendly as well. You guys are going to need places to learn these things, and so some examples of some of the facilities that we do have on campus. We have what's called the Yang Aero Makerspace. So students have opportunities to go in here, use 3D materials or make 3D composite materials. So you have a couple of 3D printers in here for class projects, some more high-end 3D printers for students who are doing research projects. Okay. Also in this particular facility is an electromagnetic working station and a woodworking shop. So students have opportunities to spend quite a bit of time in here. This is one of 5 maker spaces on campus, but I would say this one is a lot more tailored to our aerospace students. You might have some mechanical engineering students in here, but for the most part, this one's kind of tailored to our aerospace students. Okay. We also have a wind tunnel, so students have opportunities to go in here. So students who may be interested in aeromechanics, aerodynamics in some fashion will spend quite a bit of time here. Speeds in the wind tunnel go up to about 150 miles an hour. Currently renovating it so that we can double that to 300 miles an hour. So students are getting a lot of experience in here as well. And we have our Space Systems Design Lab and our Carbon Neutral Energy Solutions Center. So with our Space Systems Design Lab, this is an opportunity for our students to build a CubeSat. We have contracts with NASA and SpaceX. So basically, when they launch, we launch. And then we have our students that actually can communicate with their CubeSats through our Mission Operations Control Center. This is one of 3 Mission Operation Control Centers on a college campus. Okay, so the unique thing about this one is grad students are actually running this particular center. At the other 2, you're talking about someone who has a full terminal degree who is in charge of these operation control centers. So our students are getting a lot of the advanced knowledge pretty early in terms of what that looks like to manage and operate a control center. Okay, and our Carbon Neutral Energy Solutions Center, this is a place where students have opportunities to learn more about combustion and propulsion. This is one of 2 combustion and propulsion labs on a college campus as well. So again, a lot of advanced knowledge that students are getting on our campus. Some other examples within the Carbon Neutral Energy Solutions Center, there's a computational combustion lab, so running simulations beforehand. And then we also have a machine shop, so students have opportunities to learn how to use things like a lathes, mills, wire EDM, CNC, things like that. So other opportunities to get a lot of hands-on experience on campus. And on our website, we do have a list of full labs that students do have opportunities to take advantage of. So we highly encourage you to go there. All right. So we're going to talk about our curriculum here over the next few slides. We are going to basically talk really just about our curriculum. So this is basically going to assume that students aren't bringing in any advanced credit, but I would imagine students who are on this call are probably working with, trying to get AP credits, dual enrollment credits, transfer credits, IB credits, whatever the case may be. We will accept those. Our team doesn't evaluate those. That would be left up to admissions, okay? But they're going to look at those credits and they're going to apply those appropriately, okay? So I've had students bring in no credit at all, and I've had students bring in anywhere between the high 30s, maybe even the low 40s. Overall, I would say students are probably bringing in around an average of about an academic year's worth of work, somewhere in the mid to high 20s, maybe even low 30s. So that gives them a little time to kind of really think about how they want to plan out the rest of their time here on campus, okay? So if you're looking at AP type credits, making sure you have 4s and 5s and, your math and your physics and your chemistries. with physics, making sure you're taking calculus-based physics and not algebra-based physics, okay? Threes and fours in your composition courses, same with social sciences and your economics courses, okay? So just make sure you continue to review our website when it comes to the AP credits and things like that, all right? We have some opportunities for students to jump right in with our aerospace curriculum with the AE 1601 class. This aerospace curriculum as a whole is the most updated aerospace curriculum in the country, so we wanted students to get that hands-on experience pretty early. As we started to go through the curriculum, a lot of foundational courses like our thermofluid fundamentals and dynamics course, and then more in terms of our aerodynamics, vehicle performance, things like that, and finishing our curriculum out. Okay, so overall, our curriculum is 132 credit hours. It can be done in 4 years. Okay. So, I wouldn't freak out too bad. I think our students take roughly 15 to 16 credit hours per semester. We do have some that'll take a lighter load and then take some classes in summer. All right. We talk to a lot of our students to really kind of think about not necessarily how many credit hours they're taking per semester or what classes they're taking per semester, things like that. Because you do have some classes that, even though they might be listed anywhere between 1 to 4 credit hours, some are a little bit more manageable than others. And so, if we're taking this 2 credit hour course, some of it you might have to prepare to, think about it as a 4 credit hour course in terms of the work that you're going to be putting into that class. And so, somebody's 16 credit hour semester could be extremely manageable. And then somebody's 14 credit hour semester would be like, okay, we really got to buckle down this semester because, we've got, 2 or 3 tough classes on top of these other classes. So, those are the conversations as advisors that we're having with our students. All right. So we're still going to make sure our students are graduating in a timely fashion, but we want to make sure that our students are very strategic with their time, both inside and outside the classroom, and not, overloading themselves too much. All right. So one thing that we have started is what we call our specialty areas. So these are not concentrations. So you don't have to be an aerospace student with a concentration in aeromechanics. The goal is to get students experience in all 10 of these areas. But what we can do is provide opportunities for students to kind of tailor their degree just a little bit more. So I'm going to back up into a couple of slides. So basically, this is what's going to happen for a lot of our students. So if you see these senior areas right here where you have AE options, they're kind of in the lighter blue, okay? And then in this junior area where you see math option, we're going to talk to our students about what particular classes would work in these particular areas to kind of help tailor the degree a little bit more in terms of students' areas of interest. So if you are interested in anything that is space related or flight related, we're going to offer specific courses for our students to get those experiences in flight or in space, and kind of think more about the math classes that are going to help them as well. So those will apply appropriately within our curriculum. Okay, so those are again conversations that we're having with our students to kind of help them tailor their degree a little bit more in terms of their overall experiences on campus. All right. So some other opportunities both inside and outside the classroom. We have our Design, Build, Fly program. This is an opportunity for our students to really think long and hard about how they're doing things like autonomy, controls, aeromechanics, aerodynamics, things like that. So the Design, Build, Fly program has 2 different levels. It has the beginner level and the intermediate level. With that, I think there are opportunities for our students to take this and compete nationally. So I have provided the video from this past summer in terms of what our students were able to do. So they finished in first place in the Design, Build, Fly competition. All right, that was the intermediate level. And, that just is a running theme for our students. And I think over the last, somewhere between the last 7 to 9 years, our students have not finished less than second place in this competition. So very proud of our students who have participated in the Design, Build, Fly program, and they continue to thrive and excel. Also bring this picture to highlight Karen Phi. Karen Phi graduated from our aerospace program, and then she went away for a master's and came back for a PhD in computing. And now she is one of our aerospace professors and also an associate chair who works with students who have interest in aeromechanics, or they also have interest in humans and autonomy. So, we're very excited to have Dr. Phi on board. All right. One other program that we also have is our is our mentor in residence program. So with our mentor in residence program, this is an opportunity for our students to talk with an alum, someone who has a bachelor's, master's, or PhD. They're in the industry, they're doing well, and they're thriving. So what can me as a student ask these alums, right? So what does research look like? What was their experience like? Which labs did they work in? Things like that. And what can really set myself apart for being a future aerospace engineer. So it's about a 20-30 minute conversation with our industry leaders. And so we very much appreciate their time and their resources and being able to provide our current students a lot of different advice in terms of what to do both personally and professionally to set themselves up for a career in aerospace engineering. Some different opportunities for our students to get involved. The link that you see down at the bottom will give you all the student organizations on campus, but just to highlight a couple of organizations here, we have our Yellow Jacket Flying Club. Students have an opportunity to get their pilot's license in the Yellow Jacket Flying Club. They'll be visiting a lot of different airports and airstrips throughout the state of Georgia. Our Ramblin' Rocket Club, they have 3 different levels. There's a 8,000, 15,000, and a 30,000 foot club. The 30,000 foot club actually just went and competed last summer. They finished in second place internationally out of 100 teams. So we're extremely proud of them. There's a video out there of their accomplishments as well. So we're very, very proud of what they were able to accomplish. Their Sigma Gamma Taus, our honor society, and our Women of Aeronautics and Astronautics. It's an opportunity for our senior class women and graduate level women to work with our freshmen and transfer women on a lot of different things, getting acclimated on campus, working in a lot of different areas on campus. Some of the labs that I've mentioned, they're able to kind of work a little bit more one-on-one. And then they also have conversations about compensation in comparison to their male counterparts, making sure that their compensation is very much on par. All right. So just to highlight a few of those organizations that we do have here on campus. So speaking of compensation, this is the median salary for a lot of our students in the aerospace engineering field. We have opportunities for students to stay and get a master's degree. We'll talk about that here shortly, but you can see the compensation there. And then we have a lot of students who will stay and get a PhD as well, and most of those students are already in this, starting out in the 6-figure range. So a lot of good opportunities there for our students within this field to be very well compensated for their work. And this is where our students are working, not just working, but participating in internships and co-ops, okay? We have a couple of students this semester at Gulfstream. I have some students at Delta, have some students at NASA in Houston. So a lot of great opportunities for our students to take advantage of the internships and co-ops. We've even had some students participate in internships across the USA. So talk a little bit more about internships and co-ops. So internships is basically 1 semester. We've had students who, do internships in any semester, be it fall, spring, or summer. Typically what it would look like is, a student does their internship in fall or spring, do their internship or be in class, be in class during fall semester or spring semester, do their internship in summer, and then come back that following fall and pick up right where they left off. Co-ops are a little different in that you would basically do what's called 3 rotations. And so you would basically be going back and forth between doing rotation 1, then coming back to school, rotation 2, coming back to school, and then rotation 3, and then coming back and finishing out your aerospace curriculum courses, okay? Our internships and co-ops are paid. Internships typically range between $15,000 to $20,000. And then co-ops typically range between $40,000 to $60,000. Okay, that money is yours. We want to make sure that we have the internship and co-op documented through our Center for Career Development and Discovery. All right. So what happens with that is if it's documented, it'll show up on your transcript, and then also shows that you are a student getting full-time academic credit for this. You are not paying to do the internship. So you don't have to pay tuition for that semester or anything like that. It will show up as what we call a V credit or an audit credit, so that you can go participate in your internship and co-op. Your money is not taxed, so you will get the full 15 or 20,000 or the full 40 to 60,000. Okay, and so students use that to pay tuition if they need to, research materials, things like that. But that money is yours. And Georgia Tech is highly ranked. We're number 2 when it comes to co-op and internship placement in the country. So 80 to 85% of internships and co-ops at Georgia Tech are paid. And I have not come across an aerospace student yet who has taken an unpaid opportunity. Okay, so you're going to get a lot of great knowledge and experience at your internship or your co-op, and be able to translate that into the classroom as well. All right. So some other opportunities both inside and outside the classroom within aerospace engineering. We have some study abroad opportunities. Students who are out of state taking advantage of study abroad will pay Georgia Tech in-state tuition. This is an opportunity to take some of our classes. Let's pick on Limerick, for example. We'll have some upper division courses that are offered. Okay. Our professors are going to Limerick during the summer semesters and teaching these classes as if they were here in Atlanta. So our students will be in the class Monday through Thursday, and they'll have Friday, Saturday, and Sunday to explore. Okay, so for a lot of our students, it's an opportunity to either get ahead or catch up, because we do have some of those upper division courses that are offered there, where prerequisites, thinking about that, having to have this class in fall before you take the next class in spring. Whereas if students are going to Limerick, you have an opportunity to kind of cut that in half, instead of doing 2 semesters for those classes, 1 semester, 2 classes, we're good to go. Okay. A lot of students do participate in minors. So we have a lot of students who will do that and pair some things with aerospace. So computer science is a popular minor, math, physics, foreign languages. There's a business one called technology and management, robotics, energy systems. All kinds of opportunities that students have to pair a minor with aerospace engineering. And aerospace engineering itself, we do have a minor. So anybody who's outside of this program can think about using our program as a minor as well. And then we have our BSMS honors program. So this is an opportunity for our students to stay and get an additional year and get a master's degree. So we want to start students out in that late sophomore area, kind of around 48 credit hours. And then also making sure that our students have a 3.5 GPA. So they would need to have had 48 hours already accumulated. That's Georgia Tech hours plus the advanced credit hours that we mentioned earlier, and then making sure they maintain at 3.5. Okay. So the goal is, while they're in the program, to actually be required to do undergraduate research with a faculty member. You'll be working in their lab. You'll be working with a grad student or a research engineer, and then basically kind of think long and hard about doing a project on that research and going from there. Within that 3rd semester of research, our students need to be thinking about doing a presentation. And so one of those things that we do offer is called a brown bag presentation. So it's an opportunity for students to actually talk a little bit more about their research and then have a question and answer session. Okay. As students are participating in research, of course, they are doing classes as well. So students in the BSMS program have an opportunity to take graduate level courses and have those double count in the undergraduate curriculum as well as the master's curriculum. So that's what kind of helps speed up the timeline on the master's side for students to get that done within an academic year. And we do have some students even on the graduate side that will do an internship. So they kind of stretch that out to about a year and a half. Okay. But students who are participating in the BSMS program are graduating with a 3.5 GPA or higher. And so by Georgia Tech standards, they are graduating with high honors. So for our students to do research, for our students to participate in different clubs and organizations, and still graduate with a 3.5 or higher, that I'm extremely impressed with their level of commitment to their studies, commitment to the different clubs and organizations, and still perform everything at a high level. So Georgia Tech is very tough, as you all are probably aware. But aerospace is probably one of the tougher curriculums on courses on campus. So for our students to continue to do that and perform at a high level, I give them all the kudos in the world. So again, just harping on how great our program is. Again, very great and impressive students, but more so we also have great faculty members, 40 full-time faculty members, full professors, okay, assistant or associate professors, and then professors of the practice, okay. They have all kinds of opportunities for our students to do research, and as we've mentioned, that research turns into internships, turns into co-ops, things like that. Excuse me. And then great opportunities both inside and outside the classroom with research, with the Design Build Fly program, with the other clubs and organizations as well. So we highlight our students and what they're doing. We highlight our faculty members and what they're doing on all of our social media pages. And so we encourage you to follow us on social media and see what our students are doing and see what our faculty members are doing. All right. So I'm going to stop here and I'm going to come back to the Blue Jeans call and the chat box, and I will answer any questions that you all have. All right. And Ms. Doring has put some links here in the chat box. Thank you for that. So any questions that you guys have, be more than happy to answer them right now. Any questions? Don't feel free to jump, all at once. Feel free to put your questions in the chat box as well. I would say we have a lot of students who participate in a lot of different things, as I mentioned. So, not just research, but we've got students who are in the band. We have students who are ROTC. We have student athletes. So all of that can be done and paired well with our program. So. Yeah, I mean, we do focus on building a lot of different things. I mean, that can be, rockets. Again, the Rocket Club use a lot of the labs that we mentioned earlier to build and design that rocket. So that's one thing. And then the AE 1601 class was a smaller rocket. So, it just depends on what our students are involved in that they are building. So anything from the off-road club, building different types of cars, going from there, working and building drones, doing things like that. So, you know, they are building and designing anything and everything that you can possibly think of. In our makerspace, hanging up is a particular plane where the goal was to actually fly it backwards. They were unsuccessful, but they had fun doing it. So, whatever you want, whatever you can possibly think of, I'm pretty sure somebody else kind of has the same thought process as you. So, you can come up with anything and use any of our facilities to kind of help build and design it. So, hope that kind of answers your question. You can pretty much build anything you want or create anything you want here at Tech. And I really think that's a good thing for a lot of our students because I think other colleges do kind of focus more on some of the theoretical concepts within the classroom. Obviously, we do that as well, but we're also going to do a very good job of applying those concepts in a lot of different ways. And so, again, that's the research, senior capstone projects. We are really going to put those theoretical concepts to the test and really push you and challenge you to make sure that not only do you understand them and can apply them, but how do you really fully comprehend them and help others kind of learn those things too. So a lot of collaboration going on amongst you and your peers and your faculty members. So not really any kind of competition going on amongst anybody. Our students work very well together when it comes to building things, designing things, and helping each other succeed in this program. So I hope that kind of answers your question. Anybody else? Any other questions? If anybody came in late, I'm going to put my information in the chat box. This session is recorded, okay? So if you have questions or you want to go back and review this, you can certainly do that. So I'm going to put my information in the chat box. Aerospace systems and controls, advanced research is currently being done. Good question. Let's see. Um, So when it comes to systems and controls, I can tell you more with controls, kind of leaning more towards controls and autonomy. What I would probably encourage you to look at is a lab on campus that's called Curum. Let me see if I can find that link for you. So that is an opportunity to kind of be not just controls, but it's kind of multidisciplinary. So there's our Center for Urban and Regional Air Mobility. And so, how do you use drones in different airspaces? So, it's not just aerospace, but it's public policy, it's economics, maybe even a little bit of international affairs. So we have it here in Atlanta, and then there's some other areas where you can study this as well. But students are getting a lot of advanced knowledge, not just in aerospace systems and controls, but those other areas that I alluded to kind of think about how do we use drones and deliver goods and services to inaccessible areas. Okay, so that's one example of how students are understanding the use of systems and controls in everyday work. There are, some other, you know, kind of private projects going on right now. We do have a lot of contracts with both NASA, SpaceX, Department of Defense, things like that. So can't really speak on all of those projects going on, but students have great opportunities to jump on a lot of different projects and get the experience that they want. So I hope that kind of helps answer your question. I know I can't fully answer it, but hope I can, give you a small snapshot of some of those experiences going on campus. So there's my email address in case anybody wants a recording of today's session. Any other questions? What else you got? Good question. I'm not aware of any. I'm pretty sure they are going on right now. I'm not aware of any off the top of my head, but I can find out and I can definitely get back to you. Okay. Any other questions? Well, I hope today's session was very informative for you all. If you don't have any more questions, you are free to log off and enjoy the rest of your day, enjoy the rest of your weekend. If you do have any more questions, we'll stay on for another 5, 10 minutes and answer whatever questions you may have. Uh, Again, my contact information is there. So again, this session is recorded. So if you do have, do want a copy, again, please feel free to reach out. Otherwise, you are free to log off and go about the rest of your day. I want to thank you all for being here again. I know different time zones, things like that for, being across the state, being across the country, being international. Very much thank you all for taking the time to be in today's session and to learn more about aerospace engineering here at Georgia Tech. Thank you all so very much. Thank you. Very welcome.